fellow tech enthusiasts. Welcome back to my channel, SQL. Hi, I'm Divya, and if you are here to master SQL, you stepped into the right place. Today, we are diving into the world of keys and constraints in SQL. So you can think of keys as the superheroes of your database, alright? And constraints are the rules they follow to keep the data in check. So while let's get started. So in today's agenda, we are going to discuss about the keys, what is the importance of keys, and integrity constraints. All right. So let's dive in. So what are keys? So keys are like the backbone of a relational databases. They help us to identify records and create relationships between tables. So let's go through each of the key types. All right. First comes the primary key. So the primary key is like the VIP pass of a database. It uniquely identifies each record in a table and cannot have duplicate or null values. And remember, each table can have only one primary key. Understood? Suppose, let's say, for example, we have a table called students and we have columns like, let's say, student ID, and this is going to be name, and let's say this is going to be his phone number or something, and this is going to be grade. All right. Here, student ID is going to be the primary key. This primary key ensures that it does not have any duplicates or null values. Next comes the foreign key. So, foreign key is like a connector. So, it ensures that there is a connection between two tables. It references the primary key of another table to establish a relationship. So, it ensures that there is referential integrity. Now, let's assume that we have another table called enrollments. Alright, in enrollments, we are going to have another three columns. Let's say the one is going to be enrollment ID, and this is going to be date, and here it is going to be a student ID. So, this student ID is going to be a foreign key, and this is going to be a primary key in another table. So, this is how we are going to connect two tables. So, that is the reason we use foreign key. It acts as a connector between two tables or more tables, you can say. Next comes the unique key. So the third one is unique key. Unique key ensures that no two rows in a column can have the same value. But unlike primary key, it allows null values. You got the point, right? Suppose, let's say, for example, I have another table, and let's call this table as teachers table or a faculty table. And here we are going to have a faculty ID or a teacher ID. And we are going to have an email, and next we are going to have the courses that they are going to teach. All right. So now here, this teacher ID is going to be the primary key, and it does not have any duplicate or null values. Now what is the difference between primary key and unique key? Let's say this email is the unique key because every teacher will have a unique email ID, right? So email is going to be unique key. All right. It can be null. It must be because email is going to be unique for every teacher, but it can still be null. You got the difference between primary key and unique key, right? So let's move further. And next comes the candidate key. So a candidate key is generally a set of column or a single column that could be a primary key. The main difference is that while there are many candidate keys, there can be only one single primary key. So for example, let's say I'm going to have an employees table, and in this employees table, I'm going to have columns called employee ID, email, and phone number. So here, even with email and phone number, we can still identify the tuples, right? But we are going to use employee ID as the primary key. And then this email and phone number, either both combined or singly, will be called as candidate keys. So only one candidate key is chosen as the primary key. You got the difference between candidate key and primary key, right? Next comes the composite key. So what is a composite key? A composite key usually involves multiple columns to uniquely identify a record. Think of it like superheroes teaming up to save the day. Just like how each of the Marvel characters, be it Captain America, Iron Man, everyone has their own movies. But when it comes to saving the world from Thanos, all six of them have to combine with other superheroes, right? So this is going to be the composite key. So, for example, let's say I have a table called orders. When we go to a cafe, we order, right? So, let's say I have a table called orders, and here there are going to be three. Here there are going to be three columns. One is going to be order ID, and the second one is going to be product ID, and the third one is going to be amount. Let's say that. So here order ID and product ID together form a composite key. With these both, we can simply identify the tuples, right? So in the same way, these both combined, we are going to have a composite key. Just the way as how Captain America, Iron Man, Hulk, Natasha Romanoff and all came together to save the world, right? So this is what happens in composite key. Next comes the super key. So super key is like a candidate key with extra baggage. It is a set of one or more columns that can uniquely identify a row, but it might have extra columns that are strictly not necessary. For example, let's say employee ID and name can be a super key, even though employee ID is alone sufficient. You got the point, right? Or let me explain with the table. So now think of this as an table. This is an employee table. So we are going to have an employee ID, and we are going to have name, and we are also going to have a phone number or the department of work. All right, anything it can be. Now imagine I can simply identify the tuples with using ID, right? But I can also identify with ID and name. Here, ID and name. I can use these both to identify the unique tuples, but name is not strictly necessary. So this becomes the super key. So it includes candidate key and is any superset of a candidate key. Now, let's move on to the next one. The next one is alternate key. So an alternate key is simply a candidate key that didn't get chosen as a primary key. It's like the backup hero, ready to jump in. For example, let's look into the employees table again. So in this employees table, we are going to have an employee ID along with his name and email, right? So, according to what we have discussed previously, we can say that by using ID, we can easily identify the rows. So, this is going to be a primary key. Now, even with email, we are going to identify the tuples, right? So, this is going to be the alternate key. So, I hope you got the difference between primary key, candidate key, and alternate keys, right? So, now let's discuss about the constraints in SQL. Now that we have understood what are keys, right? So let's look into the constraints. Constraints are the rules that keep our data organized, accurate, and secure. So they ensure that only valid data makes into the database. So there are different types of constraints, and some of them are primary key, foreign key, check, not null, unique, and default. So let's look into them one by one. So the first one is primary key. So the primary key constraint ensures that the columns uniquely identify each record in the table. That means no duplicate keys are allowed. So this simply says that there should be no duplicate values inside the column. Let's say for example, in a table, if we have a column called ID, then this ID should not contain any duplicate values. That is what primary key constraint is about. Next comes the foreign key constraint. So, foreign key constraint ensures that the values in a column are valid by enforcing a relationship with another table. It's like making sure that only valid students enroll in courses. Alright, so that is about foreign key. Next comes the check constraint. So, check constraint ensures that the column meets a specific condition. It's like setting up a rule to keep things in order. Alright, for example, let's say I created a products table. So we have a products table, and this table consists of, let's say, product ID, price, and the customer ID. So let's take this is as a price column. All right. So what happens here is the price must be greater than 0, right? So the price is greater than 0. So this is going to be a check constraint. So that means every customer must order a product with price greater than 0. That means there is no free products at all. Next comes the not null constraint. In not null constraint, it ensures that a column cannot have null value. That is, no empty data is allowed. For example, let's say if there is a customer table with customer ID and name. So what I am going to do is, for name column, I am making sure that not null constraint is applied. That means there should be no null values in the name column. Alright, you got the point, right? Next comes the unique constraint. So what is unique constraint about? So unique constraint makes sure that all values in the column are different. It's like saying no duplicates here. So for example, let's say I have an employee table and we have columns like ID and email. So I want to make email as unique because it is making sure that each email must be unique in the user's table. What does it mean? Definitely, right? Suppose let's say if two persons cannot have the same mail ID. So this ensures that there are unique values maintained in the column. Next comes the default constraint. So what is default constraint is about? So default constraint sets a default value for a column when no value is provided. It's like default setting on your phone. If you don't select anything, it will choose for you, right? The same applies here too. So let's say for example, we have an orders table. So let's say for an example, we have an orders table, all right? So in this orders table, I have two columns. One is order ID and the second one is status. So in ID, generally we will have 1, 2, 3 something and all. So in status, we are going to have delivered or pending. Alright. So what I am going to do is, if the products are not delivered, then I am going to give the default value as pending. So this is how default constraint works. Alright folks, let's have a little fun. If primary key is like the lead actor in the movie, what role does the foreign key play? Is it the director or supporting actor? Let us know your thoughts in the comment below. So in conclusion, to wrap it up, keys are those which uniquely identify rows and establish relationships between tables, whereas constraints ensure that your data is valid, consistent and secure. If you found this video helpful, don't forget to like, share and subscribe. Also, drop any questions you have in the comments below. We are always here to help. Catch you in the next video. Until then, bye bye.